Welcome to David Alexander Maths Tuition. This is chapter 4f on stretching graphs. Okay, so if we've got y equals f of x, what does y equals 3f of x mean? So what this is a stretch with scale factor 3 parallel to the y-axis. So what we're doing is we're just stretching the graph like so. So this is probably the easiest to illustrate with a sine curve. So if I just show this as the sine of x, and we know hopefully that the sine of x goes up to 1 and it goes down to -1. So if I'm stretching it, I'm just pulling this upwards, and I'm also pulling it downwards as well, stretching it in both directions. With the scale factor 3 means instead of it going up to 1, it will go up to 3, and instead of it going down to -1, it will go down to -3. So let's just take a look here. So this lower line, this is y equals the sine of x with a maximum of 1 and a minimum of -1. We can see it cuts through, well, we can see both, the key thing is both graphs are cutting through the x-axis in the same place, but all we're doing is we're just stretching it vertically. So this maximum, which was 1, is now 3, and the minimum, which was -1, is now -3. So y equals the f of x versus y equals 5f of x. This is a stretch with a scale factor of 5. Again, it's a vertical stretch with scale factor 5, so parallel to the y-axis. So if this is y equals the sine of x, which goes up to 1 and -1, if I'm stretching it with a scale factor of 5, instead of it going up to 1 and -1, it will now go up to 5 and down to -5, as we can see here, hopefully. There we go. So here's y equals the sine of x, peaking at 1, and the minimum is at -1. You can see all the x-intercepts are all exactly the same. The only difference is it's just stretched vertically. So here the peak was at 1, but the new peak is 5 times that, so 5. And here the minimum was -1, and that's been stretched by 5, so it's now down to -5. Okay, so what's the difference between the f of x and the minus f of x? So here the minus is outside the brackets, so this is going to affect the y coordinates. So all we're doing is making any positive y coordinates negative and any negative y coordinates positive. So if I look at the sine of x, I'm making a positive y, I'm making that negative, and any negative y, I'm making that positive. So we can see that this is a reflection in the x-axis. So it's handy to remember that y equals minus the f of x is a reflection in the x-axis. So let's just take a look here. So here is my sine curve, y equals sine of x. So let's just label this, this is the f of x, and this one underneath, this is negative f of x, again just being reflected in the x-axis. Okay, so the f of x versus minus 5f of x. So if this is the f of x, let's say it's a sine curve, 5f of x would be exactly the same, except it's a, well, it wouldn't be exactly the same, it would be similar, but it's a stretch with scale factor 5 in parallel to the y-axis. Instead of going up to 1 and -1, it will now go up to 5 and down to -5, but the fact that it's minus means we're also reflecting it in the y-axis. So there we go, that's what it would look like if the f of x is the sine of x, then this would be minus 5 sine of x, where this point here is positive 5 and this point here is -5. So we're stretching with the scale factor of 5 and reflecting it in the x-axis. Here we go. So here is my sine curve. Y, well, the function of x is the sine of x, as we can see, goes up to 1, goes down to -1. It has been, well, first of all, we could say y equals 5 f of x would be similar, except it would be like so, but then we're just reflecting this in the x-axis. Okay, so it's a stretch of 5 parallel to the y-axis and a reflection in the x-axis. Okay, so here is when things get a little bit more confusing. So what's the difference between f of x and f of, in brackets, 2x? Okay, so this is a stretch with a scale factor of not 2 but 1/2. In other words, a scale factor of 1/2. So it's a stretch with a scale factor of 1/2. Now, if you imagine, and this stretch, sorry, would be parallel to the x-axis because this is inside the brackets. Now, I'm sure you're imagining if you're stretching something, you're sort of pulling it and making it wider, but if the scale factor is less than 1, then actually you're going to be making it, you're going to be compressing the graph. So probably the best way to describe this with the sine curve is if this is y equals the sine of x between 0 and 360, for y equals the f of 2x, we're going to be, as I say, we are stretching it with a scale factor of our half, but what it means is we are sort of compacting it. And what this means is we're actually going to get 2 sine waves for the price of 1 between 0 and 360 degrees. So that is going to be, so this is the f of x, and this is the f of 2x. Again, this point here would be 360. So, like I say, easier to visualize this with a graph that keeps going. So we can see 1 full sine wave between 360, and for the f of 2x, we get 2 full sine waves between 0 and 360. For the f of 3x, we get 3 full sine waves between 0 and 360 degrees. Okay, so a little bit messy due to my scribbling here, but so the red line, this is y equals the sine of x. It's in radians, so this would be 2 pi here, but that's don't worry about that, you'll come to that in next year, but you just, it doesn't really matter what the graph is even of, but here we can see we've got 1 full wave that starts at 0 and it ends just after 6. But for the blue one, which is it's the sine of 2x, we can see we've got 1 and then 2 complete waves before we get to that exact same point. Okay, so what's the difference between y equals f of x and y equals f of 4x? So this is a stretch with scale factor 1 over 4 parallel to the x-axis. So if y equals the sine of x between 0 and 360, this is what it would look like. And if it's y equals the sine of 4x, then what we would be doing is getting 4 sine waves in. So 1, 2, 3, 4. Oh no, missed a bit at the end there. There we go. There we go. So we would be getting 4 sine waves in between 0 and 360 degrees. And my drawing is pretty inadequate, but hopefully we can see it a bit better on Desmos. So here, this red one here, that is y is the f of x, and the blue one is y equals the f of 4x. So we can see we're getting 1 full wave up to this point here for y equals f of x, but for the y equals f of 4x, we are getting 1, 2, 3, 4. Okay, so it's a stretch with scale factor 4, so we're not pulling it out, we're actually squeezing it in. Okay, what about y is the f of x versus y equals the f of 0.5x? So this is a horizontal stretch, so parallel to the x-axis with a scale factor of 1 over 0.5 or 1 over 1/2, which is easier if we just say that that is a scale factor of 2. So what we are doing with this one is, because the scale factor is greater than 1, we are stretching it out. So if I'm demonstrating here this sine curve, so we're going to get 1 full sine curve between 0 and 360. If I'm stretching it in this direction, then I'm only going to get half of that sine curve between 0 and 360. So this is the halfway point. So between 0 and 360, all I'm going to get is the peak, that one hump like so. So I'm only going to get half of the full sine wave between 0 and 360. Let's just take a look on Desmos. So the red line, this is y equals the sine of x. So 1 full wave between 0 and 360. Okay, right, it's in radians as I said. But for the blue one, that is the y is the sine of 1/2 x or 0.5x. We're only going to get half of the wave between 0 and that exact same point on the x-axis. Okay, so what's the difference between the f of x and the f of minus x? Well, not that long ago we investigated y equals the negative f of x, and here the transformation is outside the bracket, so it affects the y values. So positive y values are being made negative and negative y values were being made positive, meaning that this was a reflection in the x-axis. Now here the transformation's inside the bracket, so it's going to affect the x values. So a positive x value will be made negative, and a negative x value will be made positive. So again, we can see this is a reflection in the y-axis. Okay, so let me just show you a curve. Let's take a look at this red curve here. This is a negative x value here, and that has been made positive here. Here we've got a positive x value, and that's been reflected in the y-axis to give us that negative x value. So again, remember that the y equals the f of negative x. That is a reflection in the y-axis. Okay, so we want to sketch the curve with equation y equals f of x. So again, it's going to cut through at 0, -3 and +1, quite similar to the last one, but I'm pretty sure the last one was +1. Anyway, it doesn't really matter. So this means we are cutting through at -3, 0 and +1. It's a positive cubic, so it's going to go up, down, then up again like so. Sketch the curve with equation y equals f of 2x. So this is a stretch, a horizontal stretch with scale factor of 1/2. So what that means is we will be squeezing the graph. So that means everything is going to get closer to the y-axis. So this this intercept of -3 will become -1.5. The 0, half of 0 is 0, and the x-intercept of 1 will become an x-intercept of a half. So the maximums and the minimums will still be the same, but everything's just a bit more squashed together. So it will look like so. So okay, again, not brilliant from my sketch there, but let's just take a look here. So the blue one, that is y equals the f of x, and we can see it's cutting through at -3. The black one, this is y equals the f of 2x. So we can see the blue line has just been squashed in with this. So that's what a scale factor of a half means. We are just so it's occupying half as much horizontal width, and that's why it's going through at -1.5 instead of 3. And here it's instead of it going through at 1, so this is 1 here, it's going through at 1/2. Okay, the point P, 6, -8 lies on the curve with equation y equals f of x. State the coordinates that P is transformed to on the curve with equation y equals 3 f of x. So here the transformation is outside of the brackets. It's going to affect the y values, so we're just going to triple the y values. So that's going to be 6 and 3 lots of -8, -24. This next example, the transformation takes place inside the bracket, so it's going to affect the x, and we do the opposite of what it says. So instead of multiplying by 6, we would divide by 6. That is going to be 1 -8.